Hello, calculus students. First of all, I want to say thank you for your patience with the Unit 1 assessment yesterday. I know that that got way more complicated than it was supposed to be. So thanks for your patience. Keep working at it. This is a tough class. These are tough questions. Keep going at it. The more practice you put into it, the more confident you'll be when you go to tackle some of those questions. So keep it up. We are going to start with Unit 2, and I honestly think that you will like this better than Unit 1 limits. Limits can be a little bit abstract. Derivatives are all about rate of change, and they are a bit more concrete. We have some rules, and math is all about rules, so I think you'll like the rules a little bit better. So today we will understand the relationship between tangent lines and derivatives. Look at the first picture with me. I have 2 points P and Q, and they're connected. Now, as a reminder, when you have a line that touches a curve in 2 points, that's your secant line. So the blue line is the secant line, and that pink or red one is your tangent line. It only touches the curve in 1 point. So what we want to know is that secant line right now, is the slope of the secant line a good approximation of the slope of the tangent line? Because we know the tangent line is instantaneous rate of change and the secant line is average rate of change. Our goal is to find that instantaneous rate of change. So when I look at this first picture, no, the secant line is not a good approximation for the tangent line. So you want to ask yourself, how do you make it better? The way that you get a better approximation is to take this point Q and slide it closer to point P. And that's what's happening in the remaining pictures. So in the next one, let's see if I can make this a little smaller. Here's point Q. It's a little bit closer to point P, so now the secant line is getting closer to the tangent line. They're getting a closer slope. Q slid even closer, so now it's a better approximation of the slope of the tangent line. And finally, in this last one, it's super, super close. So point X is getting really, really close. All right, so what we need to do is look at average velocity and instantaneous velocity again. We discussed those with limits. So I want to keep these 2 pictures together here. We have the slope of the secant line. Now from Algebra 1, we know that the slope of the secant line is y2 minus y1 over x2 minus x1. That's how we taught it to you. But if I introduce function notation in there, maybe it looks more like f of x2 minus f of x1 over x2 minus x1. Same thing, just changing the notation. But what we're going to do here is talk about a point A and a point X. So it will be f of x minus f of A over x minus A. That's the slope of the secant line. Now, here's my picture. Oops, here's my keyboard. Here's A, and here's X. So you're really finding the slope between these 2 points. It's just slope formula. It's just slope formula. It's just a slightly different notation. Now the slope of the tangent line, again, we want that second point to get as close as we can to the first point. So we want the second point to get as close as we can. So we need a limit. So we want the limit as x approaches A of f of x minus f of A all over x minus A, where the A is the first point and the x is the second point. So you want the x to get really, really close. Now, the secant line gets closer and closer to the tangent line. There is a limiting process. This is called the derivative. All right, I'm going to pause this real quick. 15 minutes till your video. All right, so the process of moving those 2 points together is the process of finding the derivative. Now, there's another way to write this formula, and this is the more common way, even though we see it both ways. So this idea up here that x is equal to a plus h, that h is the distance between the beginning point and the end point. So here's my definition of a derivative. We say that f prime of a is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. In fact, I always do that. This is at any point. Let me come back here. Make these a's for me. f of a plus h minus f of a. So this is the derivative at a specific point. What it is the slope of the tangent line at a specific point. If you want it in general form at any point, that's where I have x's in place of the a. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x. That should all be on the same line, but I'm on a space, all over h. Now, where does that come from? It's actually the same as the slope formula that we had up above. Can I make a new note right here? I think I can. I'm going to kind of zoom in over here a little bit. If I start out with, I just want you to know that I'm not making up a formula. If you write this down, cool. If you don't, that's okay too. F of x minus f of a all over x minus a. We said that this is the definition of the slope of the tangent line, right? We have those 2 points that get really, really close together. I can't see through there because my picture's there. Let's do that. Now, if I substitute a little bit, I know that f of x is really f of a plus h. So I'm going to replace the x's with a plus h. So this is the limit as x approaches a of f of a plus h minus f of a all over x we're replacing with a plus h. I'm using the substitute idea, minus a. And then what happens in the denominators, I have a positive a and a negative a, and those cancel out. So I have the limit as x approaches a of f of a plus h minus f of a all over h. So that's how I go from the first formula to the second formula. This second one is definitely more common. I've seen this more often on the released AP problems, you know, 90% of them. But then I was telling students that you didn't have to worry about the first version. And then all of a sudden I saw one of these. So the second one is definitely more common, but the first one can pop up. So I just want you to be aware of it. It's just a slope formula. It's just a slope formula. All right, so here we go. Let's pick up where we were. What does the derivative tell us? The derivative tells us the slope of a tangent, slope of the tangent line at any point. It's the slope of the tangent line at any point. And the process of finding the derivative is called differentiation. D-I-F-F-E-R-E-N-T, differentiation, a big word. We say that f of x is differentiable on the interval from a to b if f prime of x exists for all x on the interval from a to b. A couple things to note. This is not an ordered pair. It's not an x and a y, but it's really your first x and your second x. Your first x and your second x. So keep those in mind as well. All right, so when it comes to differentiation, there's a way that we have notation for that. And I know that you know in your math class, there's always new notation. So a few ways to show this. I have f prime of x means derivative, y prime means derivative, y prime of x means derivative. The first two are definitely more common. Dy dx means derivative, df dx means derivative, d dx means derivative. All of these things do. And there's one more for you, dy dx, when x equals x sub zero or x equals a. Both of those things mean the same thing. This is the derivative at a specific point. The derivative at a specific point. So if I want the slope of a curve when x equals 2, that's what we're looking at for those. All right, it's a lot of me talking about notation. What does this look like for you? How do we solve these problems? So example 1, compute f prime of 3 for f of x equals x squared minus 7x. You're going to want to write small for these. So f prime of 3 is equal to the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. So I'm finding the derivative at a specific point, which is the slope of a tangent line at a specific point. X squared minus 7x, what kind of shape was that? I should have asked that earlier. It's a parabola. I know it opens up. In fact, this one's going to have roots of 0 and 7, so my picture's not accurate. It would look more like this. I don't care how accurate it is. It's just nice to have an idea of what it looks like. It's an upward opening parabola. So what do we do with the 3 plus h and the 3? Well, you substitute them into the original function. So f prime of 3 is equal to the limit as h approaches 0 of 3 plus h squared minus 7 times 3 plus h. Everybody hates this part. This 3 plus h goes into both x terms. So all of this is f of 3 plus h. It's a big, big substitution. Minus f of 3. So now I put the 3 in for both of those. Good job. Now, I'm going to switch colors here. Here's green. So when I substitute 3 into that function, that's this piece. All over h. So this is a big, big, long problem. All right. With any limit problem, this is the whole reason we have to learn limits. This is the whole reason Unit 1 exists, in order to solve this problem. If you put a 0 in place of the h, the first piece is 3 squared, which is 9. Well, there's a negative 3 squared. I should point to that. Positive 3 squared, negative 3 squared. Those are going to cancel out. If I put a 0 in for this h, this is a negative 7 times 3, which is negative 21. Here's a negative of a negative becomes positive 21. That cancels out all over h. This is 0 over 0. That will happen every single time with these problems. Every single time. They're set up to work that way. You get 0 over 0. You have that difference of x is 0, the difference of y is 0. So you have to use all those strategies that we learned before. Well, I see something that I can FOIL out. I see something I can distribute. So we're going to simplify all this. So 3 plus h squared becomes 9 plus 6h plus h squared minus 21 minus 7h. I'm going to distribute this negative, so this becomes a negative 9 plus 21 all over h. Yes, it should look that long and expanded when you do this. That's absolutely correct. Then you want to go through and cancel things. Here's a positive 9 and a negative 9, cancel. Negative 21 and a positive 21, cancel. I can combine like terms, a 6h and a negative 7h. So this becomes f prime of 3 is the limit as h approaches 0 of negative, let's do the h squared first. My eraser's a little aggressive there. Negative, nope, see, I just did it again. H squared, there we go. Minus 1h all over h. How did we do? We got all the pieces. If you put 0 in place of the h right now, you still have 0 over 0. You're not finished with the algebra yet. Are you noticing a theme? Calculus is all about algebra. Factor out an h. So I have h minus 1 all over h. What happens with those h's? They cancel out. And now if I put 0 in place of h, I get a negative 1. Let me just double check here real quick. That is perfect. That is the correct answer. What is that we found after this long algebra problem? It is the slope of the tangent line when x equals 3. Slope of the tangent when x equals 3. That's what you just calculated. Now, eventually we're going to have a more efficient way to do that, but right now this is what we know. Using the derivative to find the equation of a line, the equation of a tangent line to y equals f of x at a specific point P, which is a, f of a, is equal to this. Let's go back to pink. Y minus f of a is equal to f prime of a times x minus a. That should look familiar to you. That's because it's a point slope formula. It's y minus y1 equals m times x minus x1. You learned that in Algebra 1. All I'm doing is changing the notation. I'm making it a little bit more sophisticated. I'm giving you function notation instead, but it's just the point slope formula from Algebra 1. That's all it is. Example 2, find the equation of the tangent line for f of x equals x squared at x equals 5. Let's get the easy stuff out of the way. What's a? A is really your x1. That's your 5. They use x and a interchangeably. A is an x that's given to you. X means the variable, it's unknown. F of a is really just your y value. So they didn't tell me what that was right away, but how would I find it? Well, you would put 5 in place of the original function. So this is 5 squared, which is 25. So we're dealing with the ordered pair 5, 25. Well, that takes care of y1, that takes care of x1. We still need the slope. So f prime of 5 is the limit as h approaches 0 of f of 5 plus h minus f of 5 all over h. So this is the limit as h approaches 0. Now we have to substitute this 5 plus h in for the x squared. So this is 5 plus h squared minus 5 squared all over h. Again, if you put 0 in, this turns out to be 0 over 0. We know we have to go back and simplify that. That's what we learned in the last unit. So 5 plus h squared, you're going to FOIL that out. 25 plus 10h plus h squared minus 25 all over h. This is the limit as h approaches 0. Yes, you should write that out every single time. My 25s cancel out. So this is 10h plus h squared over h. This is equal to the limit as h approaches 0. Factor out that h. That factor and cancel is going to be the last step, 95% of the time. And those h's cancel out. So this becomes the limit as h approaches 0 of 10 plus h. I'm left with 10. What is that 10? What did we just find? It's easy to lose sight of that. That's the slope of the tangent line. So now we have to put it all together. I'm going to choose a new color. And come over here to the left. So this is really y minus 25. There's my slope, which is 10, x minus 5. Point slope form for your line. Now, could you go through and solve for y? Absolutely. In fact, the AP calculus exam likes to do this kind of version where they add 25 to both sides. So it's not really y-intercept, it's not really point slope, it's something in between. It's a little bit different. All right, we've got 2 more that we're gonna try here. All right, example 3. Find the equation for the tangent line to the curve f of x equals 2 over x at x equals 2. Now, 2 over x is this curve. It's related to 1 over x. It happens in quadrant 1. Oh, goodness. And quadrant 3. All right, never a dull moment. All right, we're sharing again. So 2 over x is the curve that exists in quadrant 1. In quadrant 3, it looks something like that. So we want to find the equation for the tangent line. So again, you are really filling in. It's just a fancy version of the slope, point slope form, excuse me. So this is f prime of a is equal to x minus a, really just point slope form. Let's talk about the points that we're dealing with. We have a is equal to 2. So f of a is going to be 2 over 2, which is 1. I just substitute that into the original function. As a reminder, this is really your x value. The second one is really your y value. So that's the easy peasy part. What else do we have to do? We have to find the slope. So in algebra 1, we had our slope formula y2 minus y1 over x2 minus x1. In calculus, we have this derivative idea. So again, here's the longer one. F prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. Now to save on space, I'm not going to rewrite that again. My a's are really 2, so I'm just going to replace those with a 2. Use bright green. That's a 2, that's a 2. So this is f prime of 2 is equal to the limit as h approaches 0 of 2 plus h goes in place of that original x. Students don't necessarily love that substitution piece. If you're getting a little lost, reach out to myself or Mrs. Oakes. We can try to explain that one-on-one a little bit better. But this is what it looks like when it's substituted. If you put a 0 in for h, this does wind up to be 0 over 0, which means it's indeterminate. So those skills we had before, this is not a FOIL problem, this is not a factor problem, this isn't trig, but I have this 2 plus h and 2 common denominator to deal with. In my experience, students don't love this type of problem either. The way that I handle it, and depending on your algebra background, you might be looking at this a little bit differently, is I multiply by a super common denominator. I know that's how Mrs. Gomer explained it in the past. If we have, I think of this as 3 different fractions. So my common denominator among all 3 fractions is 2 plus h times 2. And if you want one for the bottom, there's really a 1 there. You don't have to write it. But if you want to be consistent, that's what you're looking for. And if I multiply top and bottom by this super common denominator, I'm only multiplying by 1, so I'm not changing the value of anything. But everything in orange here now gets distributed to this first piece. So everything here gets multiplied here. And what happens is the 2 plus h cancels out. So I am left with 2 times 2 minus, when I distribute to the second one, the 2's get canceled out. So this is a 2 plus h times the 2 on the top. And then on the bottom, I have the h, and then everything in orange stays. Nothing cancels here. So I've got 2 plus h and the 2. I'm not going to bother writing the 1. Kind of out of space for that. So this is what I have going on. This is a bit of a mess. I'll erase this when we do the next problem. So the limit as h approaches 0, 4, I'm going to distribute that 2 minus 4 minus 2h. Don't forget to distribute this negative to both. Don't distribute the denominator. I'm going to say it again. Do not distribute the denominator. If that last step is to cancel the h out of the bottom, you want it in the factored version. Do not distribute, do not distribute, do not distribute. So in the numerator, those 4's cancel out. I'm going to rewrite this again. I've seen some funky algebra happen over the years, so I'm trying to avoid that. So negative 2h, h, 2 plus h, and here's my 2. Now, this is still 0 over 0. After all that work, this is still 0 over 0. So you have to ask yourself what cancels out. Those h's cancel out. That was the whole goal. You want those to cancel out. So in the numerator, I am left with a negative 2. So f prime of 2 is equal to the limit as h approaches 0 of a negative 2 over 2 plus h times 2. You could cancel those 2's out as well if you want to, the 2 in the numerator and the 2 in the denominator. Not the one in the parentheses. And you are left with a negative 1 over 0 in place of that h, negative 1/2. What was all of that? That's the slope. Goodness, that's a lot of work. So when we put it all together, we have y minus 1 is equal to negative 1/2 times x minus 2. Now, I realize that my video is getting a little long here. I apologize, but I want to show you something. I want to show you what this looks like. We had our original function was y equals 2 over x. I want to show you that this is real and I'm not just making it up. And then we had, I wonder if I can put point slope form in here. Y minus 1 equals, I kind of feel like I can. Negative, I'm going to go with 0.5. That's really 1/2. You guys know that. And an x minus 2. Hey, that's cool. Desmos can graph in point slope form. My TI-84 cannot, but Desmos can. So that red curve is the original curve. And the blue curve is my tangent line. So we just calculated all this by hand, which is very cool. We said, here is the point that we're dealing with. There we go. Well, label it for me 2, 1. And look at that. You calculated a beautiful tangent line. That looks awesome. So that work that you're doing by hand is true. It works. So you have the 2 over x, and then you have the equation of the tangent line. So I think that's pretty cool. You may not think it's as cool as I do, but that's okay. All right. Last idea here. I'm going to just kind of scroll down here on the bottom. My pencil is not behaving today. There we go. Find all the points on f of x equals x cubed plus 12x plus 4, where the tangent line is horizontal. Now, if we're doing this by hand, this is a lot of work. Let's do this in terms of x. Hold, please. All right, we're back. So instead of using a specific point, we're going to use the variable x. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, when I go to substitute this into the function above, it's going to look a little funky. We have the limit as h approaches 0. This has to go in for both of those x's. So this is x plus h cubed minus 12 times x plus h plus 4. All of that is the first piece, minus x cubed minus 12x plus 4. That's the second piece, all over h. This is a big, big, big problem. Now, the x plus h cubed, you have to FOIL it out twice, or if you look up your sum of cube rules and all that other stuff, but I'll FOIL it out twice for you. So this is x plus h, and x squared plus 2xh plus h squared. I'll distribute that negative 12, so negative 12x minus 12h plus 4. I'll distribute this negative, negative x cubed plus 12x minus 4. Now, can you see how missing one negative along the way is going to make a big problem? Be careful with that. Can you also see how terribly inefficient this is? We have a better way. You just got to be patient with me. You kind of have to muddle through this, and then the good stuff comes. So this is x cubed. I'm going to distribute this, by the way, plus 2x squared h plus xh squared plus, now I'm going to distribute the h through, hx squared plus 2xh squared plus h cubed. Yikes, all of that is FOILing that out. Now, just to save myself some space, I think I have a negative 12x cancels with a positive 12x. I have a positive 4 cancels with a negative 4. That'll save me a little bit of writing. Minus 12h minus x cubed all over h. All right. I think we have some like terms to put together here. X cubed. Here's an x squared h, so this is 3x squared h, xh squared, so I've got 3 of those, 3xh squareds, plus h cubed, minus 12h minus x cubed, all over h. All right, what else cancels? Hopefully you see it. I see a positive x cubed and a negative x cubed. Every other term remaining has an h, and that's exactly what we should have. And the reason why that's exactly what we should have is because that h has to factor out to cancel with the h in the denominator. So we're in good shape. It doesn't feel that way, but we are. So there's an h. So this is 3x squared plus 3xh plus h squared minus 12 all over h. Looking good. Again, those h's must cancel out. Now, don't forget the last step. H is 0. So this is going to be 3x squared. Those two terms that still have h's drop out, minus 12. When I see you again, we're going to be able to solve this whole problem. Let me look at it. In under 5 seconds, and 5 seconds would be slow. So be patient. But you do have to get through this. You do have to get through this. All right. I want to know, where is the tangent line horizontal? Horizontal tangent line has what slope? Horizontal means slope equals 0. So we are going to come down here to this derivative that we found and set it equal to 0. Bravo. Solve for x. I'm going to factor out a 3. Now, I'm going to factor with difference of squares. My solutions are -2 and +2. That's where I have a horizontal tangent line. I apologize for the long video today. Bear with me. I want to show you one more time what this looks like. Let's get rid of our old stuff. We had y equals x cubed minus 12x plus 4. Stretch it this way. We said we had horizontal tangent lines at -2. There it is. And +2. There it is. Can you imagine a horizontal line going through those 2 points? So again, I want to show you that it works. I'm so excited that this works. Try the practice problems. Yes, they are long, but you have to do the long ones before we can get to the shortcut. Be patient, persevere through these. It will be okay. Calculus is like this. There are tough days, there are easy days. There are tough days, there are easy days. But the easy days are worth it when you get through the tough days. So reach out if you have questions. You know how to contact us. Good luck.